You know, every single diesel truck you see on the road is running on fuel that's been through this incredibly high-stakes purification process. So today, we're going to pull back the curtain on the heart of that system, the hydrotreater. It's this absolute beast of a machine that runs on a constant, really delicate balancing act of temperature, pressure, and chemistry.
So let's start with a really basic question. Why is your diesel fuel so clean in the first place? Well, it's because the stuff that comes out of the ground, crude oil, is anything but. It's a raw, messy, complex soup that needs a major cleanup. See, raw crude oil is just loaded with junk you do not want anywhere near a modern engine or, frankly, the atmosphere. We're talking about things like sulfur, nitrogen, and even trace metals like vanadium and nickel. These compounds, they're corrosive, they're toxic, and they can completely destroy the expensive catalysts used later in refining. So before it can become fuel, all that stuff has to come out.
And that purification process, it's called hydrotreating. It's a game of precision right from the very first step. It all starts with creating the absolute perfect mixture before the real action even begins.
And here is where that precision really kicks in. Operators have this kind of magic number they live by, around 160. That means for every 1 cubic meter of oil, they need to mix in about 160 cubic meters of hydrogen-rich gas. Now, this isn't just a suggestion. It's a critical control parameter that sets the stage for absolutely everything that's about to happen.
So why that exact number? What's the big deal? Well, it's actually doing 3 super important jobs all at once. First, it stops gunk, we call it fouling, from building up on the super expensive catalyst. Second, it acts like a heat sink, getting ready to absorb some of the crazy amount of heat that's about to be generated. And third, it just makes sure the whole mixture flows properly through all the pipes and heaters. It's the perfect setup for the main event.
Okay, now we're heading into the fiery heart of the hydrotreater, the reactor itself. This is where those contaminants get chemically ripped out of the oil in a series of pretty intense reactions. And managing this beast, it all comes down to one thing: absolute, unwavering control over the temperature. This quote, it's from an actual operating manual, and it says it all. This isn't some set-it-and-forget-it process. An operator's main job is to manage these temperatures hour by hour. Because if you get it wrong, well, it doesn't just ruin a batch of fuel. It could put the safety of the entire plant at risk. So how in the world do they manage it? Well, you can think of it as this 3-step dance. First, a charge heater brings the feed up to the precise ignition temperature. Then, as the reactions kick off and generate this massive amount of heat, cool quench gas is shot in between the catalyst beds. It acts like a fire extinguisher, soaking up all that excess heat and stopping a dangerous temperature runaway. And the whole time, a huge network of thermocouples is feeding real-time data back to the control room, giving the operator a perfect picture of what's happening inside.
This graph right here shows you exactly why that control is so critical. Look at the curve for desulfurization, removing sulfur. It happens pretty easily. But now look at the other curve for saturating aromatics. That's the reaction that really boosts fuel quality, and you can see it needs much tougher conditions to work. That's the tightrope operators are walking. They have to crank the temperature just high enough to hit those difficult reactions, but without overheating the whole system.
Okay, so great. The main reaction was a success. The sulfur and nitrogen are gone. But, in solving one problem, we've actually created a new one. The process itself made some nasty byproducts that are now in the stream, and we have to deal with them, like right now.
So here's the issue. Those reactions created hydrogen sulfide and ammonia. As the stuff coming out of the reactor starts to cool down, these two gases love to combine and form something called ammonium salts. And if you let them, these salts will literally solidify, clogging up and corroding all the equipment downstream, like heat exchangers. The solution, though, is surprisingly simple, almost elegant. You just inject a stream of clean wash water into the hot mixture. The water dissolves the salts and just carries them away safely before they can cause any trouble.
But of course, it's not as simple as just hosing it down. There are very strict rules. You need to inject enough water so that it actually stays liquid. Otherwise, you can create some really nasty acidic conditions. You also have to keep that salt concentration below 8%, or it'll start eating away the pipes from the inside. It is yet another example of this incredible balancing act.
All right, we're on the home stretch now. The product is clean, the corrosive salts are gone, but it's still all mixed together. Liquid fuel, water, and that recycled gas. So the final step is to separate everything out and make the product stable.
First, the whole mixture flows into a high-pressure separator. You can basically think of this thing as a sorting hat. Using really precise pressure control, it splits the stream into 3 different parts. You get the hydrogen-rich gas, which is cleaned up and sent right back to the beginning of the process. You get the sour water with all those dissolved salts, which goes off for treatment. And finally, you get what you came for, the liquid hydrocarbon product.
But that hydrocarbon isn't quite ready for your car just yet. It heads to one last piece of equipment, the stripper column. In here, steam is bubbled up through the liquid, and it literally strips out the very last traces of any dissolved gases. What comes out of the bottom is the final product, pure, stable, ultra-low sulfur diesel, finally ready for the pump.
So if you pull back and look at the whole process, a really clear theme emerges. Running a hydrotreater isn't about pushing one big button. It's much more like conducting an orchestra, where every single instrument has to be perfectly in tune with all the others.
This entire process is just one delicate balance after another. Take temperature. Too low, and the reactions just don't work. Too high, and you permanently destroy your expensive catalyst. What about the hydrogen ratio? Too little, and the catalyst chokes on carbon. Too much, and you're just wasting a ton of energy and money. And the water wash? Too little means corrosion chews up your equipment. Too much can throw the whole downstream system into chaos. Every single variable is a constant, high-stakes balancing act.
And all of this leaves us with a final big-picture thought. We know that the crude oil that's available to refineries is getting heavier, dirtier, more contaminated, and at the exact same time, environmental fuel standards are only getting stricter. So the question becomes, how will these incredibly precise control strategies need to evolve to meet the challenges of tomorrow?